we are given three forces that are acting on a point. The first force is 10 newtons acting at 0 degrees. The second force is 10 newtons acting at 120 degrees. And the third force is also 10 newtons acting at 240 degrees. We are asked to find the resultant sum of these three forces. Now, since force is a vector quantity, that means to find the resultant force of these three forces, we have to find vector sum of these three forces. So the three given forces are F1, force 1, it is 10 newtons at 0 degrees. The second force is F2, it is also 10 newtons, but it is acting at 120 degrees. And the third force, F3, this is also 10 newtons at 240 degrees. We have all heard that a picture is worth 1,000 words. Pictures and diagrams, they're especially useful in physics. They help us understand concepts and visualize problems. So this problem, in which we are given three coplanar force vectors, let's go ahead and draw a diagram for this and we'll go from there. So first thing we're going to do is draw an XY plane. Why? Because the three vectors given here, they are coplanar. So here we go, plus x, plus y, minus x, and minus y. The first force, which is 10 newtons, it is along the positive x-axis. So here we go. This is our force F1. Let's go ahead and label it F1. And it is at 0 degrees. The second force is acting at 120 degrees. So I'm going to try to draw the vector for force F2 the same length as the vector for F1. Since I'm doing it freehand, these two vectors may not be exactly same in length. So here we go. This is our vector F2. So here we go. This is our vector F2. And it is at 120 degrees from the positive x-axis going counterclockwise. Our third vector, F3, that is also 10 newtons. That is, it's going to be equal in length to F1 and F2. And this is at 240 degrees going counterclockwise from the positive x-axis. So here you go, 240 degrees. So let's go ahead and say angle for force F1, it is theta 1 and it is equal to 0 degrees. And the angle for force F2, that's theta 2, is 120 degrees. The angle for force F3, it is theta 3 at 240 degrees. Now to find the sum of these three vectors, there are different methods. We could use triangle law of vector addition, in which we could first add F1 and F2 and find the resultant of F1 and F2, and to that resultant add F3. Or we could use parallelogram law of vector addition, where again, first we add two force vectors, and to the sum of those two force vectors, we add the third and the remaining force vector. Or we could add all the three vectors together using the polygon law of vector addition. The last method is the analytical method of vector addition. And this is the method that we're going to use to solve this problem. So what do we do in the analytical method of vector addition? In the analytical method of vector addition, what we're going to do is we're going to find the x and the y components of these three forces. And we're going to add the x components together to find the x component of the resultant force. And we're going to add the y components of these three forces together to find the y component of the resultant force. Once we have the x and the y component of this resultant, then we use the Pythagorean theorem to figure out the magnitude of this resultant force, and we're going to use some basic trigonometry to find the angle of the resultant force. All right, let's go ahead and figure out the x and the y components of these three force vectors. Let's first talk about the first force, F1. So we want to find F1x and F1y. Now the force F1, it is at 0 degrees. That means all of this F1 is along the positive x-axis here. If all of F1 is along the positive x-axis, that means no part of this F1 is along the y-axis. So we don't even need to calculate the x and the y components of force F1. The fact that F1 is aligned along the positive x-axis tells us that F1x is 10 newtons and F1y is 0. But if you insist to use formulae, then we could do that as well. The formula for F1x will be F1 cosine theta 1, which is 10 newtons for F1 and cosine of 0 degrees. Theta 1 is 0. And likewise, F1y will be F1 sine theta 1. That gives us 10 newtons times sine of 0 degrees. All right. Now cosine of 0 degrees, what is this equal to? This equals 1. So 1 times 10 newtons, that gives us 10 newtons. So F1x is equal to 10 newtons. Moving on to F1y. Sine of 0 degrees equals 0. 0 times 10 newtons is 0. So F1y is equal to 0. Here, we have gotten the value of F1x and F1y. Moving on to force F2. We are now going to find the x and y components of the force F2. We're going to delete everything from this diagram except for the x and y coordinates and the force F2. Here we go. To figure out the x and the y components of the force vector F2, drop a perpendicular from the tip of F2 onto the x-axis. So here, this distance over here, which one? This one here. This is going to be F2y. And this distance over here is F2x. So what I'm saying is this here. Let me redraw it. So here we go. This is F2y, the vertical component. The hypotenuse, it is the length of the vector F2. And this horizontal line, it is F2x. So this is 90 degrees angle. It's a right triangle. The hypotenuse is the magnitude of the vector F2. The vertical component, it is F2y. And the horizontal component is F2x. So basically, this triangle is nothing but this triangle over here. Okay. All right. We know that the vector F2, it makes an angle theta 2 from the positive x-axis going counterclockwise. What would be this angle over here that the vector F2 is making with the negative x-axis? Let's call that equal to theta 2 prime. Here we go. Let's call this angle equal to theta 2 prime. So here we go. This is theta 2 prime. what is theta 2 prime equal to? That is going to be 180 degrees minus theta 2. Now to calculate the value of f2x and f2y, we have two options. We could either use the angle theta 2 or we could use this angle theta 2 prime. They will both give us the same answer, except when we use theta 2 prime, we have to pay attention to these signs. How? Well, look here. This vector f2, what quadrant is it in? It is in the second quadrant. In the second quadrant, x is negative and y is positive. That means f2y will be positive and f2x will be negative. So let's go ahead and write that down real quick. If the vector is in the second quadrant, then its x component will be negative. That is, it's less than 0, or I can say negative. And its y component will be positive. Here we go. Now let's go ahead and calculate f2x and f2y. f2x, I could use the actual real angle, theta 2. And that would give me f2x equals f2 cosine theta 2. f2 is 10 newtons, cosine of 120 degrees. Now cosine of 120 degrees, that is in the second quadrant, and cosine is negative in the second quadrant. So here we go. When we use the real angle as is measured from the positive x-axis going counterclockwise, f2x comes out to be negative automatically. Let's move on to f2y. f2y will be equal to f2 sine theta 2. That gives us 10 newtons times sine of 120 degrees. Sine is positive in the second quadrant, so f2y will be a positive number. Alternatively, we could have used angle theta 2 prime. Theta 2 prime is the angle that f2 makes with the negative x-axis. f2x, so use this triangle over here. In this triangle, we know f2 and we know theta 2 prime. Using f2 and theta 2 prime, we're going to calculate f2x and f2y. Simple basic trigonometry. f2x will be equal to f2 cosine theta 2 prime. Okay, cosine theta 2 prime, it will be a positive number, because as you can see that theta 2 prime as it is defined is less than 90 degrees, and cosine of an angle that is less than 90 degrees is a positive number. That means we have to insert a negative sign here by hand. And when we do so, what do we get for f2x? We get negative, f2 is 10 newtons, cosine of 60 degrees. All right, so what do we get for f2x? We get minus 10 newtons times cosine of 60 degrees. It is equal to 1/2. So f2x, it is equal to minus 5 newtons. Moving on to f2y now. It is equal to f2 sine theta 2 prime. We are calculating the value of f2y in terms of the known quantities, which is the magnitude of vector f2 and the angle that f2 is making with the nearest x-axis in the quadrant that it is located in. And f2 is in the second quadrant. So theta 2 prime is the angle that f2, the vector f2 is making with the negative x-axis. And in the second quadrant, f2y should be a positive number. So let's go ahead and calculate the value of f2y. f2 is 10 newtons times sine of 60 degrees. Sine of 60 degrees is a positive number, and we know that f2y should be a positive number. So we do not have to insert a negative sign here by hand like we did in the case of f2x, where we had plugged in this negative sign. All right, so sine 60 degrees. Sine 60 degrees is equal to square root of 3 divided by 2. So here we go. f2y equals 5 times square root of 3 newtons. f2y. All right. Now we're going to move on to finding the components of the vector f3. All right. So vector f3, it is in the third quadrant. That means f3y, that should be a negative number, and f3x, that should be a negative number as well. Once again, there are two methods to do it. First is use the angle 240 degrees, which is theta 3. Alternatively, we could use the angle that f3 is making with its nearest x-axis, which is the negative x-axis. And that angle is, let's say, theta 3 prime. And theta 3 prime will be equal to what? That will be equal to theta 3 minus, and theta 3 prime will be equal to theta 3 minus 180 degrees. All right, so f3x, it is f3 cosine theta 3. This is going to be 10 newtons times cosine of 240 degrees. Cosine of 240 degrees, it's a negative number. So f3x will turn out to be a negative number on its own. We have to do nothing from outside. We do not have to insert a negative sign in front of the number that we are going to calculate for f3x. It is going to be negative on its own. Likewise, when we calculate f3y using theta 3, that will also be a negative number. Why? Because sine is negative in the third quadrant. So f3y is 10 newtons times sine of 240 degrees. Alternatively, we're going to use the angle theta 3 prime, which is going to be equal to what? Theta 3 minus 180 degrees. Theta 3 is 240 degrees. What is 240 degrees minus 80 degrees? That is 60 degrees. So here we go. Our theta 3 prime is 60 degrees. All right, so f3x, that will be equal to f3 cosine theta 3 prime. That is going to give us 10 newtons times cosine of 60 degrees. Cosine 60 degrees is a positive number, but we know that f3x should be a negative number. So what we're going to do is we're going to put a negative sign here by hand. So what do we get here now? So that gives us f3x is equal to minus 10 newtons times cosine of 60 degrees. Cosine of 60 degrees is equal to 1/2. So f3x is equal to minus 5 newtons. Moving on to f3y. f3y is f3 sine of theta 3 prime, which is 10 newtons sine of 60 degrees. Now we know that f3y should be a negative number, but sine 60 degrees is not negative, and nor is the magnitude of the vector f3. That means we have to again put a negative sign here by hand. Let's go ahead and do that. So we put a negative sign here. What do we get? Minus 10 newtons times sine of 60 degrees, which is square root of 3 divided by 2. So F3y is equal to minus 5 square root of 3. So F1x is equal to 10 newtons and F1y is equal to 0. Next, F2x and F2y. F2y was equal to 5 times square root of 3 newtons and F2x was equal to negative 5 newtons. Moving on to the F3. F3x is also minus 5 newtons and F3y, it is negative 5 square root of 3 newtons. Now to solve for the final resultant force, what we need to do is we need to add these x components with each other. What does this give us? This gives us Fx, the x component of the final resultant force. So when we add these x components, what do we get? We get Fx to be equal to 0. And similarly, we have to add these y components together to get Fy. Fy is the y component of the final resultant force. And once again, you will see that Fy is equal to 0 when you add F1y plus F2y plus F3y. Now to get the value of the final resultant force, we would use Pythagorean theorem using Fx and Fy. But since Fx and Fy are both equal to 0, F is equal to 0. So the final resultant force of these three vectors is equal to 0. And let's go ahead and draw a diagram to understand this a bit better. Now we're going to draw the x and y components of the three force vectors here on this diagram. Here is the x component of the vector F1. So this is F1x. It is 10 newtons. Let's go ahead and now draw the x component of vector F2. We know that it is minus 5. This is F2x. It is equal to minus 5 newtons. Now we're drawing the x component of vector F3. This is minus 5 newtons as well. I know my drawing is not perfect, but hopefully it is making sense to you. Here we go. Next, we are going to draw the y components of vector F1, F2, and F3. We know that the y component of force vector F1 is 0. The y component of the force vector F2, it is 5 square root of 3 newtons. So here we go. This is F2y. It is 5 square root of 3 newtons. Next. Now we are going to draw the y component of the force vector F3. And that is negative 5 square root of 3 newtons. So here we go. F3y equals negative 5 square root of 3 newtons. When we add these components, we are going to add the components along the x-axis with each other. X component of F2 and F3. They are together minus 10 newtons, which cancels out F1x, which is positive 10 newtons. And likewise, the y component of F2, which is 5 square root of 3 newtons, it cancels out the y component of F3y, which is minus 5 square root of 3 newtons. You can think of this point as a ring. It's a big ring that is being pulled by 3 kids with equal force, and these forces are 120 degrees apart from each other. The resultant of these three forces will be 0. These three forces, they are at equilibrium. Now these three coplanar forces that are equal in magnitude and separated from each other by 120 degrees, when they act on a single point, these three forces cancel each other out, and this point, or in this case this ring, it will not move at all. So this problem, it is actually a very classic problem. It's a very interesting problem. And in this case, these three forces, they cancel out because of the angle 120 degrees between these three equal forces. You should try a variation of this. Let's say F1 is 10 newtons at 0 degrees. F2 is 10 newtons at 135 degrees. And F3, it is also 10 newtons at 225 degrees. Your assignment is to find the resultant of these three force vectors. So find the resultant force of these three force vectors. I will put the answer for that in the description for this video.